In 2012, Felix Baumgartner stepped out of the stratosphere from an altitude of 39 kilometers. He broke the sound barrier with his own body, reached a maximum speed, and survived. But what would happen to a human if they decided to jump onto other planets of the solar system? This plunge into the abyss will reveal the forces and phenomena that rule each world. What kind of death awaits him where life is impossible? To give him a chance, I outfitted him with a new generation spacesuit made of titanium and heat-resistant materials. The suit can withstand immense pressure and extremely low and high temperatures. But even such protection may not be enough. This is not just a jump. It is a step into the unknown. Let's start with Venus, the planet closest to us. In terms of size, it is Earth's twin, yet this resemblance is deceptive. The surface of Venus is a veritable hell, characterized by extreme pressure and temperature. Acid rain pours down here, yet there are no lakes or seas. Were you to find yourself on Venus without a protective suit, the planet's atmosphere would simply crush you. And so, our astronaut takes a leap from an altitude of 40 kilometers. During the first 5 kilometers, he accelerates rapidly. Both temperature and pressure begin to rise. He hurtles through layers of clouds composed of sulfuric acid and carbon dioxide. At an altitude of 35 kilometers, he breaks the sound barrier. The pressure is now equivalent to that found 500 meters beneath the ocean's surface, and the temperature stands at 200 degrees. His spacesuit continues to withstand the extreme forces as the astronaut draws closer to the Venusian surface. The automated systems engage the braking thrusters. Touchdown. He has landed safely. His spacesuit is glowing red hot, though the cooling system is functioning nominally. However, the sulfuric acid immediately begins to rapidly corrode the suit. The protective shielding is disintegrating. Death. Congratulations. He survived on Venus for a mere 20 minutes. And now, let us fly to the outer reaches of the solar system, a realm where cold and darkness reign supreme. Before us lies Neptune, a gas giant where familiar notions of a planetary surface cease to exist. There is no solid ground here. Beneath your feet lies a colossal ocean of super-dense fluid and gas. You begin to sink instantly. The deeper you descend, the more rapidly the pressure mounts. Within the mantle, it is millions of times greater than Earth's and capable of crushing any object. This is the windiest planet. Its hurricanes reach enormous speeds. A year here lasts 165 Earth years. Since its discovery, Neptune has completed only one orbit around the Sun. From here, the Sun appears merely as a bright star. He plunges downward, piercing the blue atmosphere. Its outer layers consist of hydrogen, helium, and methane, which gradually transition into a dense mantle composed of a mixture of methane and ammonia ice. Unfortunately, due to the immense pressure on the planet, our astronaut's jump spells certain death. It is believed that deep within the planet, under the influence of extreme conditions, carbon crystallizes into diamonds. Perhaps, in the depths of Neptune, a veritable rain of diamonds is falling. Far from the Sun, it has become inhospitable, far too cold. I turn the ship around and we head for Mercury, the first planet, where we can once again feel the fiery embrace of our Sun. Mercury is almost entirely devoid of atmosphere. Here, nothing cushions the impact of meteorites, and nothing retains heat on the surface. Altitude, 50 kilometers. All around, nearly a vacuum. He simply falls, silently, like a stone. But what if the braking thrusters fail to fire? He would slam into Mercury at tremendous speed, gouging yet another eternal crater into its surface. Yet, at the very last moment, the thrusters roar to life. His velocity drops and he touches down. Overhead, the stars. There is no atmosphere, only the vacuum. Then, suddenly, a white orb flares into existence on the horizon. Here, the sun switches on like a searchlight, yet the sky remains black, even in broad daylight. The surface temperature begins to climb. The spacesuit holds firm. But it was designed to last for days, not months. And on Mercury, the sun will continue to shine for another 88 days. Before long, the cooling system begins to fail. The spacesuit turns into an oven. The astronaut perishes. Now, course set for Mars, the red planet. It seems almost familiar, yet this is a deception. The atmosphere here is so thin that it offers almost no resistance to a falling object. The atmospheric pressure is 150 times lower than on Earth. There is nothing to breathe. The atmosphere consists entirely of carbon dioxide. All around lies the cold. The spacecraft is at an altitude of 40 kilometers. The descent feels almost like falling through a vacuum. Speed builds continuously. By the time it reaches the surface, its velocity will be immense. But then the engines ignite. The astronaut touches down, kicking up a cloud of dust. Martian dust, fine and clinging, seeps into every crack and crevice. After that, almost nothing happens. There is no instant incineration from searing heat. There are no oceans here to drag you down to the depths, no acidic storms. And for a fleeting moment, it seems as though this planet poses no threat whatsoever to a human clad in a spacesuit. All around, the silence is almost tedious. It is only toward evening that the planet comes to life with a beautiful Martian sunset. Right around the sun, a kind of magic unfolds. A cool blue halo blossoms around the golden disk, and a thin line of azure glides along the horizon, a stark reminder that you are no longer on Earth. But enough poetry. Mars, too, will kill a human, just not immediately. Supplies will run out: oxygen, water, energy. And if a base is not established on the planet, the explorer will perish from sheer depletion. And now, let us fly toward 4 distinct, yet fundamentally similar worlds: the gas giants. Our astronaut has already visited Neptune, so we know what that experience is like. Remarkably, all these planets possess ring systems. However, while Saturn's rings are massive and visible from afar, those of the other giants are thin, almost invisible. They were not discovered until the late 20th century. Jupiter is the largest planet in the solar system. Orbiting it are more than 90 moons, creating a miniature world within the larger solar system. A massive vortex, the Great Red Spot, rages across the planet's surface. It is so immense that it rivals the Earth in size. We are now approaching Saturn. It is a planet instantly recognizable by its rings. Although the rings span hundreds of thousands of kilometers in diameter, they are merely tens of meters thick. Composed of water ice mixed with dust, they reflect light, making them visible from vast distances. And here is a fascinating detail. At the planet's north pole lies a perfect hexagon, as if an invisible hand had traced it directly onto the clouds. Saturn, too, possesses a multitude of moons. To date, 146 satellites have been identified. Next is Uranus. It appears to be lying on its side. Its axis is tilted at a full 90 degrees. Like a colossal bowling ball, the planet rolls along its orbit around the sun. Uranus is an ice giant, not because its surface is sheathed in ice, but because beneath its atmosphere lie hidden layers of ices, ammonia, and methane. It is the methane that imbues the planet with its serene turquoise hue, and much like on Neptune, diamonds rain down deep within its interior. I wish to spare our astronaut's life, for were he to attempt a landing on these planets, he would simply be crushed by the immense atmospheric pressure. With this, our planetary tour of the solar system comes to a close, and I am steering our spaceship home. Yes, you might ask, but what about Pluto? However, astronomers have excluded it from the ranks of the solar system's planets. A planet must be the dominant object in its orbit, whereas Pluto shares its orbit with thousands of icy bodies in the Kuiper Belt. It is merely one of these bodies, albeit the largest one. Therefore, we will not be flying to it. It is too small and not a standalone planet to serve as a target for an interplanetary mission. Our journey has come to an end. If you found this interesting, please leave a like and subscribe to the channel. It motivates me to create something truly cosmic in my future videos. Thanks for watching until the very end.